See, when any object is moving on the circular path with speed v, then v square by r, that is the centripetal acceleration, because the acceleration that is towards the center. Now we already studied about second law of motion. So second law of motion suggests this thing, the force that is mass into acceleration. So here if we multiply this centripetal acceleration by mass, then we will get the force that is mv square by r, m that is the mass of body, okay, and the direction of this force, that will be in the direction of acceleration. So we can say when the acceleration is a centripetal acceleration, this force is a centripetal force. So in short, we can say this thing, if we want to sustain the motion of the body which one is moving on the curved or circular path, then the required centripetal force, that is mv square by r. If this much force is not provided to it, then definitely that particular object or the body will slip off. Okay. Now we know this thing, whenever the body moving on the curved path and it slip off, then it always slip off in outward direction. But when it is not slipping off, it implies that the required centripetal force is provided. Now, who provide this one? So, required centripetal force is provided by friction. Now, see here, suppose we think about the motion of a car on level curved road. Level means horizontal curved road. Okay. So, on the car, the forces acting, weight that is in downward direction, normal reaction that is vertically upward, and the frictional force that is towards the center, which will provide the required centripetal force. Now, when the car is moving on the horizontal curved path, at that time vertical equilibrium is there. It implies that the vertical forces are perfectly balanced. So we can say N and mg are perfectly balanced. So N that is equal to mg. Okay. And now see here, the force towards the center, that is the frictional force. So we can say this thing, the frictional force will provide the required centripetal force to sustain the motion of the vehicle. Okay. Now see, frictional force provide the required centripetal. So we can write F equal to mv square by r. Now see, if we increase the speed, mass and radius of curvature, that is constant one. So if we increase the speed of the vehicle, then required centripetal force will increase. Now we know this thing. The friction that is self-adjusting, so it will also increase, but the maximum possible friction, that is mu s into n, it implies that we know this thing, the friction F that is less than or equal to mu s into n. So mv square by r, that should be also less than or equal to mu s into n. So we can write v square, that should be less than or equal to mu s into n into r upon m. Now n equal to mg. So v square is less than or equal to mu s mg r upon m. M cancelled. So we can write v, that should be less than or equal to under root mu s r g. So maximum permissible speed on that particular horizontal curved path having radius of curvature equal to r, that we can write v maximum equal to under root mu s r g. So this one is the maximum safe speed. If your vehicle move on that particular path with the speed greater than this one, then definitely it will slip off. Definitely it will slip off. But here see, very important thing that you can observe in this equation of maximum safe speed, the mass of the vehicle is not appearing. It implies that for the given horizontal curved path, the maximum safe speed for each and every vehicle, that is same one. If you move on that particular curved path on two-wheeler or four-wheeler, or if the truck is moving on that particular path, then each one must have to move with a speed less than this one, because this one is the maximum safe speed. If speed increases than this one, then definitely that vehicle will slip off. Clear to all of you?
Yes,